Hello and welcome to the AI Research Roundup. I am Alex, your host. Today is May 8th, 2025. Alright, we are looking at a research paper from Hugging Face's List, published about 2 weeks ago, titled, Generating Answers from Complex, Interrelated Contexts. This paper tackles how language models struggle when information is messy, say with conflicting or outdated details across different documents. It introduces a framework called Context Organizer, or CORG. Context Organizer helps by sorting these varied pieces of information, or contexts, into groups, aiming for clearer, more accurate answers. So to understand the challenge Context Organizer addresses, this first figure really sets the scene. It shows a collection of information, or a corpus, about The Simpsons episodes, where a user is asking for the total number. You see different snippets or contexts with varying details, like Season 2 having 18 episodes in one, but 22 in another. The colored dashed lines illustrate how these contexts can be distracting or present counterfactuals, which are statements that are not true, or be ambiguous, or simply duplicates. This kind of tangled web is very common in real-world information. Building on that idea of tangled information, this next plot really quantifies the problem. It shows us how answer recall, which is basically a measure of how well the model can find the correct answer from the given information, changes as we add more of these problematic contexts. You can see that counterfactual contexts, those untrue statements we mentioned, cause the most dramatic drop in performance. Distracting and ambiguous information also significantly reduce answer recall, while duplicated contexts, well, they are the least harmful. This clearly shows why organizing these contexts is so important. Alright, so given these challenges, how does Context Organizer actually tackle this? This diagram lays out the Context Organizer framework. We see a user's question, like, how many episodes do Simpsons have? And the corpus, that collection of documents. First, a graph constructor analyzes all the different contexts, say context 1 through context 5, mapping out their relationships. Then, a re-ranker organizes these contexts into groups. For instance, putting related context 1 and context 4 together. Finally, an aggregator processes these groups to create a comprehensive answer, even noting conflicting details with sources. Okay, so we have seen how Context Organizer is designed to work. Now, this plot really highlights its practical benefits when it comes to efficiency and performance. It is showing us the trade-off between these two. Efficiency here on the horizontal axis is measured in flops, that is floating point operations per second. Essentially, it is a way to count how many calculations the computer has to do. You can see Context Organizer, labeled CORG, right up there, achieving very high performance while using relatively few flops. The light yellow color, as indicated by the scale, shows it has the best balance between performance and computational cost, closely followed by the summarize method. So moving from that efficiency plot, this table gives us a detailed look at the actual performance scores. We are seeing results for different language models, like Llama 2, Llama 3, and various GPT models, tested on datasets called AmbigDocs Plus and Conflict QA Plus. These datasets are specifically designed with those tricky, mixed-up contexts, across various context handling methods including k-means, which is a clustering algorithm to group contexts. Context Organizer consistently shows strong results, often in bold as the best, or underlined as second best, particularly excelling among the grouping strategies. Following up on those strong results, this table then details what happens when we start taking parts away from Context Organizer. It is a kind of what-if experiment. We see the full Context Organizer, or CORG, at the top with a score of 22.0. Then, different versions are listed, like one without removing duplicates, which is a re-ranker function, or another without grouping, also from the re-ranker. The score drops with each removed feature, particularly when grouping is omitted, or when all these specific re-ranker and aggregator functions, marked with R and A respectively, are taken out, dropping the score substantially. This really shows each piece is doing important work. So, as we have seen from those ablation results, every component of Context Organizer is indeed vital. The big takeaway here is that language models often struggle when faced with real-world information, that messy mix of distracting, ambiguous, and even counterfactual contexts. Context Organizer provides a structured way to handle this by first mapping relationships and then grouping related context for clearer processing. This leads to better answer recall. That is, getting more complete answers and improved disambiguation, or sorting out confusing details efficiently. That is all for this AI Research Roundup. Thanks for joining.